All right, problem 14. We're given two equations here. Let's call this equation A, let's call this equation B, so we can tell them apart. We have equation A is y is less than 2/5 x plus 3. Equation B is y is greater than 1/2 x minus 6, okay? Which of the following tables are all the values of x and their corresponding values of y solutions? Looks like there's a typo. What it's asking is, in which of the following tables are all the values of y, x, and the corresponding values of y solutions to the system of inequalities shown? So it's asking which one of these are always going to be in the solution set. So let's do the easiest thing possible, right? They gave us a lot of space here too. So let's make a graph of our lines, and then we can see exactly what kinds of solutions will fall within them. Since we have a y-intercept of 3, we're going to definitely count up to 3. We have a y-intercept of -6. And again, this is just pulling directly out of our equation, right? So anytime we have y equals mx plus b, and this can be a less than, it can be a greater than, we know that m is going to be our slope, and b is going to be our y-intercept. So we're just pulling out our b. So for the first line, A, we know that our y-intercept is going to be 3. So let's go up 1, 2, 3. Let's go 4 and 5 too. Then for B, we know the y-intercept is at 6. So we go down -1, -2, -3, -4, -5, -6. We'll got one more, -7, and -8. Might as well. And then over to the right, let's just complete our graph because we're doing it already. 1, 2, 3, 4, 5, 6, and -1, -2, -3, -4, -5, -6. We have our y-axis, we have our x-axis, always label them. It's always good practice to label our axes. Axes is the plural of axis, if you didn't know that. So then we have our point for A, which is 0, 3. We have our point for B, which is 0, -6. Now all that's left to do is to use our slopes to find some other points, okay? And this is best practice whenever you're graphing an equation in terms of y and x, and it's in slope form, it's in slope-intercept form. Graph the intercept, use our growth triangle to find the next point. So for example, for A, we have our point 0, 3. So we have our rise over run, our m equals rise over run. So 2 is our rise, and 5 is our run. So we'd go up 2, over 1, 2, 3, 4, 5, to get our point, which is up 2 from 0, or up 2 from 3, and over 5, so our point is 5, 5. You could also use the slope equation to get that point 2. So we can go down 2, just like we can go up 2, and over 5 we can go down 2, and to the left 5, 1, 2, 3, 4, 5, to get this point, which looks like it's going to be at 1, or -5, 1. Okay, and we can see our line. And this line is going to be called A, because we have A up here. Now are we done? Not quite. This is going to be a dotted line, remember? Because it's a less than, it's not a less than or equal to. And then shaded is going to be the region all beneath it, because it's less than, okay? So it's going to be everything down here. All right, now our second equation we have is 0, -6 is going to be our y-intercept. And our growth triangle is going to give us up 1 for the rise, to the right 2, because it's positive, up 1 over 1, 2, up 1 over 1, 2. We can see that our points are 2, since we went over 2, -5, and then like 4, -4, and then like 6, -3, just using our graph to find the points, right? Like this, right? Those are all our points. So we can draw a line for this one. Let's find some points over here too. Down 1 over 2 to the left, because just like we can go up 2 to the right 2, or up 1 to the right 2, we can go down 1 to the left 2, and that's the same thing. Down 1 to the left 2. And these will be like points -2, -7. And then this last one is going to be -4, -8. Okay? And then we can draw our line, which is going to be a dotted line, but just for simplicity. So then this is our line, and then it says greater than. So that's going to be like all this area up here. So we can see that the area where it's going to be solutions to the system of inequalities, that just means it's a solution for both of them, okay? So we want points that exclusively lie in this region because it's below this line and it's above this line, which means it's going to be between both of them, okay? So our solutions are all bounded by this region, this kind of area that kind of looks like a sideways rectangle or a parallelogram. So then to check our answers, what we're going to have to do is directly verify. So for example, -2, -8. Is that one inside? Is this point here inside? No, it's not, which means none of this can be correct, right? A can't be correct because this one's not inside our area. So then again, -2, -8 can't be that one. So how about -2, 3? -2, 1, 2, 3. That lies on it. We'll come back to that one. 0, 2. That one does. 4, -3. 1, 2, 3, 4. 1, 2, 3. That one does. All right, let's table. Let's come back to it. Remember, this one was kind of an iffy one. So then we have, for D, we have -2, 2, which is like here. We have 0, -3, 0, -3. And then we have 4 over 4, 3. Okay, so these are the points, right? Remember the iffy one, this is D's points. I'll mark them. And these are C's points. So this one is right on the line. So if that one's part of it, then it's going to be C. But remember, we have a dotted line. These are dotted lines, which means they don't include it because Y has to be less than it on top, and it's got to be greater than it on the bottom, which means they're dotted, okay? That's how we denote that. So it's greater than, which means it cannot lie on the line. Like for example, if X is greater than 7, X does not equal 7. That's a big no-no, right? So because it's less than the line, it can't lie on the line. So because C lies on the line and it's supposed to be beneath the line, it cannot be C, which means our answer is left with D. Because all those points do indeed lie inside our parallelogram-ish region.